Welcome back again to my channel Chemistry Made Simple for NEET. I am Dr.Lekshmy Subramaniam with a PhD in Chemistry. Today in this session we will continue our quick revisions of some of the MCQs from the lesson Hydrogen of class 11. As I said already, we have 4 parts of MCQs from hydrogen and I've already finished the first and second part. Today I am going to continue with the third part. So before moving on to the questions, let me tell you something about the key to success in the NEET exam. So there are certain strategies to be followed to make revisions effective and efficient. So I am briefing some of the revision techniques followed by the NEET toppers during their days of NEET preparation. So I will tell you one by one. Today I will tell you the first strategy. You have to make a revision schedule. The first step before beginning your preparation for the NEET exam is that you need to draft a timetable for yourself. It is important to allocate 2 slots particularly for revision. The time slots can be based on your convenience, but it is advisable to have 1 revision slot in the morning before beginning the day's preparation and 1 in the evening at the end of the day's preparation. So, we will start with the questions now. First question with the MCQ today is, hydrides made from group 1 and 2 are known as A. complex hydrides, B. ionic hydrides, C. metallic hydrides and D. covalent hydride. Answer is option B, ionic hydrides. These are made from group 1 and 2. So, except for beryllium and magnesium, heating these elements in hydrogen, we can get their ionic hydrides of the corresponding elements. So these are normally white colorless crystalline solids with high melting point and boiling point. So it can be easily decomposed by water, carbon dioxide or sulfur dioxide. Next question is, what is used for removing the last traces of water from organic compounds? How can we remove traces of water from organic compounds? So what is it that we use for removing water? A. hydrogen, B. lithium aluminum hydride, C is ionic hydrides and D is molecular hydride. The choice is C, ionic hydride. So these ionic hydrides are extremely strong reducing agents. Normally alkali metal hydrides are used for making lithium aluminum hydride, sodium boron hydride, etc. Also they are used to remove last traces of water from organic compounds. So next question is, molecular hydrides are formed from A. F block elements, B. P block elements, C. D block elements and D. S block elements. So answer is B. P block elements. So molecular hydrides, otherwise known as covalent hydrides, why they are formed by elements of P blocks with higher electronegativity than hydrogen. So again it can be divided into electron deficient hydrides, electron precise hydrides and electron rich hydrides. Next question is, which is an example of electron rich hydride? A. methanol, B. methane, C. aluminum hydride and D. ammonia. Answer is D. ammonia. So electron rich hydrides are what? They are hydrides with a greater number of electrons, which is normally required to form normal covalent bonds. Examples are hydrides of group 15, 16, 17, etc. The excess electrons in these hydrides are present as lone pairs of electrons. Next question, methane is an electron dash hydride, poor, deficient, rich, precise. The answer is precise. This is what are electron precise hydrides. They have an exact number of electrons needed to form normal covalent bonds. So normally group 14 hydrides like methane, silicon hydride, etc. So these are the hydrides of group 14. Next question is, interstitial hydrides are also called as A. complex hydride, B. molecular hydride, C. ionic hydride and D. metallic hydride. The option is metallic hydride, otherwise known as interstitial hydrides, formed when transition metals and rare earth metals combined with hydrogen. So these are covalent hydrides, whereas ionic hydrides are formed from S block elements. Next question is, metallic hydrides are powerful dash agents, oxidizing, reducing, combining or separating. So answer is oxidizing. Choice is A, oxidizing agent, but actually metallic hydrides are powerful reducing agents formed by the combination of transition metals and rare earth metals with hydrogen, showing metallic properties. So the answer should be choice B, reducing agent, and it's wrongly marked as choice A. So sorry, it's choice B. These are reducing agents. So metallic hydrides are powerful reducing agent is the correct answer. So you can see that some questions and when little bit printing errors come. So just take notice of these points, and when you take out the printouts for these such questions, you strike it out option A here and put option B instead, and don't make the mistake of learning the wrong option. Okay, next question is LAH 2.76 is an example of A molecular hydride, B metallic hydride, C covalent hydride, and D ionic hydride. So the answer is metallic hydride. So the composition varies with temperature and pressure, and these are non-stoichiometric in nature, and LAH 2.76 is an example. These are found when transition metals and rare earth metals combine with hydrogen. So the hydride gap is related to group A 7 or 8, B 7, 9, C 7, 8, 9, and D 8, 9. So the answer is option C 7, 8, 9. Metals of these group do not form hydrides under standard temperature and pressure, and so this periodic table region, that is called hydride gap. So water is of how many types in hydrated salt? A is 1, choice B is 5, C is 4, and D is 3. So choice B, 5 types are there in hydrated salt. The 5 types of water are coordinated water, hydrogen bonded water, lattice water, clathrate water, and zeolite water. The next question is the type of hardness which occurs due to the presence of bicarbonate of calcium and magnesium ions. Hardness is A. What type of hardness is it? Half hardness, temporary hardness, permanent hardness, or momentary hardness. So the choice is B, temporary hardness. So the water normally forms comes with soap, which is known as water doesn't lather with hard water. It gives form or lathers only with soft water. Why the hardness occurs? Because of the presence of bicarbonates of calcium and magnesium, which is temporary hardness, which can be removed by boiling or Clark's process. Now, what is the most efficient method to get water with 0 degree hardness? Is it electrolysis, B permuted process, C synthetic resins, or D Calgon process? So answer is B, permuted process. So permuted is what? It's a hydrated sodium aluminum silicate, and it exchanges the sodium ions for divalent ions of calcium and magnesium. So when fully exhausted, permuted can be regenerated by treating it with 10% of sodium chloride solution. Now, which of the following is a method of removing temporary hardness? How can you remove temporary hardness? A, boiling, B, adding washing soda, C, adding caustic soda, or D, adding sodium phosphate. The answer is A, by simply boiling itself or by Clark's process. You can also add washing soda, caustic soda, or sodium phosphates to here. These are added for removing the permanent hardness of water. What is Calgon? It is A, potassium phantom metaphosphate, B, sodium pentametaphosphate, C, potassium hexametaphosphate, D, sodium hexametaphosphate. Calgon is sodium hexametaphosphate. So permanent hardness can be removed by Calgon process. So Calgon is actually it is sodium hexametaphosphate. Chemical formula is given by Na6P6O18. So what is hybridization of water? A, sp(D), B, sp3, C, sp2, and D, sp. Answer is B, sp3 hybridization. So in water molecule, oxygen has 2 lone pairs and 2 bonded hydrogens, and the structure is like V shape and has got a bend structure. Chemical formula, as you know, for water is H2O. So with that, we are coming to the end of part 3 MCQs of hydrogen. Hope you all will take a printout of these sessions, or you can even keep it saved as a file, so that in future you can do easy reference for the questions just before exam for quick revisions. So please do like, subscribe, and share my channel with your friends. And with that, we are coming to an end of this session, and I'll be soon uploading part 4 of hydrogen MCQs. So thanks for watching my video.